Hello class, welcome to another Ed puzzle video. 4.3 right triangle trig. And please take out a note paper and pencil so you can follow along. So, we're doing right triangle trig and we're doing it based off of the Ed puzzle from before, 4.2 with Sokatoa. So, just to reiterate, the example says find the exact value of all 6 trig functions, and it would give you a triangle like this where they give you 2 of the pieces, but you're missing 1. And one thing I would like us to remember is for right triangle, to find the other side, remember since it's right triangle, we can always use Pythagorean theorem, which is a squared plus b squared equals c squared. And just to put it on the right triangle, you could put a, b, and c is always the hypotenuse. Alright, now that I got that, I know it's going to be a squared plus 3 squared equals c squared, which is, whoops, getting ahead of myself, 5 squared. Once you do that, you get a squared plus 9 equals 25. And then you know it's going to be a squared equals 16. And then you get a equals 4. So now I know that this is equal to 4. Now that I got all of the sides of my triangle, we just do Sokatoa. Sine is opposite, so the theta is right there. Opposite is 3 over hypotenuse, which is 5. And actually, let me use a different color so we can. So it'll be 3 over 5. Cosine is adjacent over hypotenuse. The adjacent one is 4 over 5. And then tangent is opposite over adjacent, which is 3 over 4. And then cosecant is the reciprocal of sine. So instead of 3 over 5, it's 5 over 3. Same thing with secant, opposite of cosine, so it's 5 over 4. And then cotangent is the reciprocal of tangent, which is going to be 4 over 3. Simple enough. So let's try this one. I want you to try this. So please do this one on your own, where I give you a triangle. And your theta is right here, and I give you 12 and 5. So please take your time to do this, and once you are finished finding all the exact value of the 6 trig functions, so what I mean by that is find sine, cosine, and tan, and also find cosecant, secant, this is E by the way, and tan, or not tan, cotangent. So please use this triangle to help you solve for the 6 trig function. Once you're finished, we will continue through the video. Alright, now that you've done this one on your own, let's see how you did. So using Pythagorean theorem, you should have gotten 13 right here. And after you got 13, all you gotta do is opposite, which is 5 over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then, cosecant is just 13 over 5, the reciprocal of cosine, and then the reciprocal of tangent. All right. I also want you to try this one. This one's going to be a little more tricky. And it's asking you to find cosecant of, so you're looking for theta if A equals 19 and B equals 19. And in triangle A, B, C, and C equals 90 degrees. So please do this one on your own. And once you are finished, you have to look. Remember, you have to find what cosecant of A is. Once you find that, we will continue. All right. Now that you did this one on your own, let's see what steps you took to get to the answer. So first off, I know it's gonna involve a triangle because we had triangle A, B, C, and it says C is my 90 degrees, so I know that the box will be right there. And then I know that we have 19 on each side for A and B. And you could have thought, okay, maybe I gotta use Pythagorean theorem to solve for this. Or if you notice, both sides are equal to each other, so we know that it's 45, 90 triangle. And 45, 45, 90, we know that it's x, and x square root of 2. So I know that this right here is 19 square root of 2. And I know cosecant. So now we're like, okay, cosecant of A equals hypotenuse over opposite. And regardless, the opposite is the same, so it's 19. But you know the opposite would have been right here. So we have 19 square root of 2 over 19. And that would have been your answer. If you didn't understand that, please ask questions, or hopefully this helped you see how we would have solved for this. All right. So let's go on to the next note, which is example 2. But same thing, evaluate. Oops. My writing is not the best. All 6 trig function. I'm going to leave function as fun because we know those are always fun. And then let's say we are given A, and it says tan equals 3 over 4. I know 3 over 4 is opposite over adjacent. So now that I got that, I can draw my triangle. So I know theta is going to be right here. Opposite is 3, so the opposite should be this one over adjacent. And I'm just missing my hypotenuse. We know Pythagorean theorem, this should give you 9 plus 16, which is 25. Square root of 25 is 5. And after that, we found our, triangle. And we were able to draw this triangle out. So, for part B, you have secant theta equals 7 over square root of 13. please do this one on your own, and once you are done, just draw the triangle, and also give me, I know I didn't do it in part A, but also give me all the other trig functions that are missing. For example, find sine, cosine, tangent, cosecant, etc. All right. Now that you've done this one on your own, let's see how you did. So we know that secant is hypotenuse over adjacent. So we know if we're drawing the triangle, it would be, so theta's right here. We know our adjacent is 13. We know our hypotenuse is 7. And if you did this, it would be A, I would call this right here A squared plus 13, or square root of 13 squared equals 7 squared, which is going to be 13, or A squared plus 13 equals 49. You put 13 to the other side, it will be 36. Square root of 36 is 6. And after that, we could just find our trig functions. And that'll just be opposite over adjacent, which is 6 over 7. Cosine would be, cosine was a little easier to find because you could have just done the reciprocal of this. And that would be square root of 13 over 7. And then tangent theta would have been opposite over adjacent, so it would have been 6 over square root of 13. Just remember to simplify because we can't have a radical in the bottom. So we would get 6 square root of 13 over 13 once we simplify that. And then cosecant theta is 7 over 6. Secant we got earlier, but I want to fix it because it's 7 over square root of 13. So we get 7 square root of 13 over 13. Because remember, we have to simplify that. And then lastly, we have cotangent, which is opposite of tangent. Or I would just use 6 over square root of 13, because if you do the opposite of that, the reciprocal, it would be square root of 13 over 6. And that would be our final answer for all of that, since we said we had to evaluate all the 6 trig function and find it using what we were given. All right, so let's do this one. Example 3. So we are given, it says 60. We have 6 right here and x. And we're missing a side length. So we know that cos is adjacent over hypotenuse. So we could do cosine of 60 equals x over 6. And then we try to solve for x. So we multiply each side by 6, and we get 6 cosine of 60 equals x. And then we know the cosine of 60, if you remember for your unit circle, which should be 6 1/2 e 1/2 equals x. And then 6 times 1/2 is x equals 3. So now let's do something different. This one says, ooh, my triangle is not pretty. That's okay. Let's say that we are given, this is 14. and this is 7.7, and we're looking for this angle right here because this is the missing angle. What we could do is we can use tangent because we have opposite over adjacent. So we have opposite over adjacent, and so we can use tan theta equals 7.7 over 14. And then to solve for theta, we have to do the opposite tan, I think it's what it's called, or inverse tan, which you do tan -1 of 7.7 over 14. And this one would require a calculator, and you would get 28.8 degrees. And once we get to there, we are done with our notes. I know this is a lot of review, but please, write all these stuff down, or at least follow along, see if you understand it. And this should either be a review or this could be something new for you. All right, if you have any question, comments, or concern, please leave it now. Otherwise, please enjoy your day, and thank you for watching.